Have you ever really thought about how you send money? How it goes from point A to point B? We're about to dive into Bitcoin, which is a whole different way of doing things. It's built on this really wild idea. What if we didn't need to trust anyone to manage our money? So let's unpack how this system without trust actually works.
So look at this. On one side, you've got your typical financial system, right? A handful of big players at the center controlling everything. But on the other side, you've got the Bitcoin vision, a wide-open, distributed network, where we're all peers. This is the whole ballgame. Bitcoin was built to flip the script, to go from a system of central control to one where we all agree on the rules together.
And you know, the timing here was absolutely no accident. Bitcoin wasn't just some random idea. It was literally born from the ashes of the 2008 financial crisis. When the whole system was shaking, its anonymous creator Satoshi Nakamoto dropped this into the world in January 2009. It was a direct answer to the massive failures of the banks.
And this quote from Satoshi, it just cuts right to the heart of the matter. It's about this idea of forced trust. We have to trust banks with our money. We don't really get a choice. But as we all saw, that trust can be broken, big time. Bitcoin was designed from the ground up to get rid of that need for trust altogether.
Okay, so how in the world does it actually do that? Well, if you boil it all the way down, Bitcoin is shockingly simple. It's just a computer program. A program that lets a whole bunch of computers all share and agree on a single file. Seriously, that's the core of it. And that one special file, that's what we call the blockchain. Just think of it like a giant public spreadsheet that lists every single transaction that's ever happened. And because everyone on the network has their own copy, there are no secrets. It's completely transparent. This shared list, this ledger, is the bedrock of the whole system.
But wait a minute. This raises a huge question, right? If there's no bank, no central server giving the thumbs up to transactions, what stops me from sending the same digital money to two different people? Copy and paste. This is the famous double spend problem, and it's the big puzzle that any digital cash has to solve. And this right here shows you the dilemma perfectly. Let's say one person tries to be sneaky and sends the same coin out twice. Some computers on the network will see the first transaction, others will see the second. So, now what? Who's the referee? Who gets to decide which payment is the real one? The solution is just brilliant. Instead of a single referee, Bitcoin creates a massive, ongoing, network-wide competition.
We call this competition mining. About every 10 minutes, computers all over the world are racing each other for the right to bundle up the latest transactions and add them to the official record. The winner's version of the story becomes the truth for everyone, and any conflicting transactions, like that double spend attempt, they just get tossed out, ignored.
So what does this competition actually look like? Well, it breaks down into 3 basic steps. First, a miner grabs a bunch of recent transactions. Second, they mash all that data together into a unique code. And third, they have to find a winning number, and the only way to do that is to guess, over and over again. And finding this number, it's not about being clever. It's a pure, brute force lottery. Miners are basically guessing numbers, millions, even billions of times per second, hoping they'll stumble upon one that fits the rules. And as you can imagine, that takes an absolutely insane amount of computer power. So you're probably thinking, why would anyone spend all that money on electricity and computers just to guess numbers? Well, the incentive, the prize. The miner who wins the race gets rewarded with a batch of brand new Bitcoins that were just created out of thin air. This is called the block reward, and it is the only way new Bitcoins ever enter the system.
Now, these batches of transactions, these blocks, they aren't just separate files. Each new block is mathematically locked to the one that came before it. It creates this long, unbreakable, and ever-growing chain of blocks. And there you have it. That's literally where the name blockchain comes from.
This chain design is what makes the whole history of transactions so incredibly secure. If a bad actor wanted to change a transaction from the past, they wouldn't just have to solve that one block's puzzle. They'd have to redo all the work for that block and every single block that came after it. And they'd have to do it faster than the entire rest of the network combined. It's pretty much impossible.
All right, so let's zoom in on what a transaction actually is. A good way to think about it is like moving stuff between super secure digital safe deposit boxes. When you send Bitcoin, what you're really doing is using your key to unlock the funds in your box and then creating new locked boxes that only the person you're paying can open. And what are the keys to these boxes? Well, you get 2 of them. First, there's your public key. This is like your bank account number. You can give it to anyone, no problem. But then you have your private key. This is like your password. It's the secret that lets you open your box and spend what's inside. You guard this key with your life.
Now, here's the really cool part. When you decide to spend your Bitcoin, your private key creates a unique digital signature for that one transaction. It's mathematical proof to the entire network that you and only you are the owner of those funds. But, and this is the magic trick, you prove it without ever having to show anyone your private key.
Okay, let's put it all together. Let's walk through the entire life of a single transaction. It all starts with ownership. You have a private key that controls your funds. Then comes creation. You use that key to sign off on a payment. Next, to broadcast that transaction out to the whole network for everyone to see. Then you wait for confirmation. That's when a miner picks it up and includes it in a winning block. And finally, immutability. Once it's in the blockchain, it's there forever. It's part of the permanent, unchangeable history.
So does this whole thing actually work at scale? Well, the numbers are just staggering. To date, this global, decentralized network has processed more than 153 million transactions.
And the amount of value that this system has secured is even more mind-boggling. It has moved over $12.8 trillion worth of value. That's trillion with a T, all without a single bank or CEO or company calling the shots.
So when you put all these pieces together, what you have is a global payment system that has been running nonstop 24/7 for over a decade without a single central point of failure. It's this open project that just runs on pure math and competition. And it leaves us with a really big question. What does it mean for our world when our trust in institutions can finally be replaced by our trust in code?